our next two speakers, we go back a long time. Mike Lubliner and Dave Bohac are going to be talking about how to try to do some of this stuff on multifamily buildings. So please give a warm welcome to Mike and Dave.
Thanks, Joe. Thanks, everybody. Appreciate it. I'm going to do a little real-world feedback working with some public housing authority, King County Housing Authority, and their experiences with Aerobarrier that are kind of unique in gut rehabs. And then Dave's going to talk a little bit about some of the research that we're starting with some utilities on existing buildings. So first thing is I want to give a shout out to Dan Auer and Jesse Bennett. They're both here. You guys want to stand up? We'll get a picture of them later, but talk to them because I'm going to throw a lot of stuff out about what they're up to. They're a leading public housing authority that's doing pretty innovative stuff, including Aerobarrier. I want to thank Mike Lyons, Aerobarrier, Dave, Colin Olson, who helped me with some of this stuff, and some of the folks that shared their data. And of course, with Andre, who can't be here today, and of course, Joe and Betsy. So let's talk a little bit about King County Housing Authority. They're the largest public-private partnership, and they're the biggest landlord in the state of Washington. They provide assistance to over 50,000 people, rental housing assistance. And I'm going to focus on low-rise multifamily woody walk-ups. Does everybody know the term woody walk-up? I don't know if it's politically correct, but in any event, most of them are non-corridor, but about 50-50 have corridors, and that's a whole nother bear. They typically have individual mechanical and individual metering, no central systems, although some of the projects are moving forward. And as you'll see, they're doing some really cool deep energy retrofits in the low-rise multifamily. They also do single family, and they also purchase and operate manufactured home parks, which they try to revitalize. So the first thing we'll talk about is the Windsor Heights in Seattle. It's a gut rehab. So all these focuses on gut rehab. And we talked about embodied energy and, taking down an old building that's built in the 60s and building a whole brand new building there. Affordable housing is a limited amount of money. There's housing crisis. So they're looking at gut rehab and start with the building that's already there. So I'm going to be focusing on it. The first one, quite often back in the 60s, they had car decking. Does everybody know what car decking is? It's kind of all right. Anybody don't know? All right. And what this one was using a injection of Aerobarrier in a vented crawl space and having it, instead of doing the innie to outie, the outie to innie, so to speak. So here's a little shot there of a blower door in there to pressurize the crawl space. So basically, we wanted to get rid of all the old rat piss R19 bad insulation that was falling down in there. And one of the things you need to do when you do this kind of application is it doesn't go through insulation, so you need to remove the insulation. In a lot of cases, these gut rehabs or retrofits, the insulation needs to be removed for a number of different reasons anyway. So that's part of the assessment of, how effective is it? Can you pull it off? Somebody that's regularly removing old insulation where you can find all kinds of stuff. I hear Jimmy hop his fingers up in one of those crawl spaces. Anyway, so we seal the vents, then we put it, we inject, and then we put R30 back in. Here's an example of, these were two buildings. They had 10 units each. And basically, the building, could you see which one got the most reduction? That was the one with the Aerobarrier. It was a 44% reduction so that was pretty good compared to what they were typically doing with standard air sealing. And again, I'm not going to get into details, just trying to show you that there's some really interesting applications that are coming down the pipe, and King County's been doing this for a while and learning, and we're still learning. And here's Colin. Colin helped me. This was some tech-like files that looked at each of the apartments and over time, the noisy part, and then you get to the where everything's at equal pressure. And the upper apartment's a little leakier than the others. But this was the apartment with 5,451 CFM. Next one went down to 4319. So we got some good reduction there with this system. The Evergreen Terrace, again, a gut rehab, but this time the car decking is in the ceiling over a vented attic. And then the approach here was to go into these gut rehabs and do it in innie to outie. And so they were basically sealing between units as well as attic. This had some wall, and they had slab on grade. In 14 buildings, 50 units, there were 60, it was upgraded since 63 when it was built. We pressurized unit by unit. We sealed the attics and the walls. Didn't have too much to worry about with the slab. And then they take the old insulation out, get rid of Jimmy Hoffa's finger, and put in R49. This is built tight, ventilate right. They're getting these homes really, what's that? Car decking, it's like T&G flooring that goes together. It's really hard to seal. 2x6.
Or used for railroad car, freight car decking, that's why.
That's how, thank you, Rick, you got my back again. And you'll do it tonight when you're playing. All right, and so anyway, they really did a good job on this. They were able to really get some reductions, and you can see they build tight, ventilate right. They put in ducted HRVs, and this unit's got ductless heat pumps, so they got AC. Wow, that's a benefit. And here's an example of the reduction. And so, you know, this is the kind of stuff we like to see. Before, after, significant benefits, really, really hard to seal car decking. So for that vintage of housing, this could be a really interesting application. It's particularly big, I hear, in Oregon and Washington and Northwest. And then finally, I'm going to show a new project, which is one of the biggest, largest affordable housing rehabs in the state. Some is new construction, but most of it was gut rehabs, and they're all woody walk-ups. You can see on the left side, there's these 3 mechanical units. Those are CO2 heat pump water heaters. On the right is the individual meters. So these 27 buildings, 325 units. It's about 80% complete, slab on grade, 3 stories. They did a non-guarded test. So they're looking at the total leakage with the windows open in the adjacent units when they test. It was built to the Washington State Energy Code, which is a pretty aggressive code that has energy credits that you need to get in addition to the minimum backstop of insulation and efficiencies. And in this project, they were trying to just use electric resistance heat.
28 code?
Yeah, I believe so. And then, so they took the credits of the build tight, ventilate right credits, which was the tightest shell they could get, and then they were able to achieve that. It was pretty innovative. And then, as I said, they put in a CO2 central heat pump water heater. Ecotope's been involved in that. It's coming up, and now they're actually serving multiple apartments with their hot water. And there's PV on site. No cooling in this project, no AC. And here's some results for the woody walk-ups. The red line is the code. That's, you want to be below the code there. And this is it by units. And these were the units that were newly constructed. It was about a 27% below the 0.25 CFM 50 per square foot of surface area. And some of the results here, again, we had targeted about 0.25. We got an average. This was one building, and we did really well. I must say, a lot of the builders, I used to do the energy code training, answer the hotline in Washington State, and people would call me up and they'd say, I want to get that credit with the HRV and down to 2 ACH 50, you know, and I'd say, have you ever sealed a house? Have you guys have got a good crew? And I'd always tell the building officials, the builders, you better have somebody on Aerobarrier speed dial if you don't know what you're doing. And that's not to say you can't do this without it, but it's been very effective in getting to the passive house levels that the code requires. So here's just some cost information from one of the contractors. King County, it can really leverage costs with their purchasing power, and they get some good contractors that use them over and over. It's a really good entryway into low-income housing with partners that are reliable. Some cost of what it typically costs to remove the insulation in the attic, depending if it's loose fill or bat. And they typically, you know, require in their specs that all the joints be sealed. And with the attic insulation and existing insulation removed, it's about, you know, it's somewhere around 60 to 65 cents per square foot. So looking at removing the old and air sealing without Aerobarrier, about 250. So we're going to see how much difference we can get with going with the Aerobarrier and getting a much tighter shell. So some future research, what we want to do is, and we were hoping to do this until DOE took all our funding back, but we're doing it, so, and Dave will talk about that. We want to look at stakeholders. What do the stakeholders think about this? You know, they're the ones that King County partners with private people that own these buildings, and they want to see value proposition. And then I also work with the low-income weatherization program at Oak Ridge, the WAP program. And they look at SIR, savings to say the cost benefits. And what we want to do is some parametric analysis, like, you know, what if you were able to get the labor down to this? What if you were able to get the cost? How tight does it need to be? And look at where the sweet spots for different types of buildings. And as I said, it's all about the research of what the stakeholders think. The tenants, the builders, the contractors involved, the utilities that are funding a lot of this, the weatherization crews that are involved, and the King County, other King County contractors involved. What we want feedback is on odor control. They care about odors. Somebody's smoking a joint in the apartment, the kid's in the manger, the bed in the next apartment. That's the real world. And so Dan is asking, how is this going to affect the builders? How is it going to affect odor control? These are things we want to learn more about. Sound control is another one, you know. Thermal comfort, indoor air quality, we heard a lot about that today. And then what are the investment ratio and the impacts on demand and energy use? And are there any other non-energy benefits? So we're going to be looking for research partners to continue, and we'll be working with King County and the Northwest to try to investigate things and come back with share in the future. So it's the kind of things they're doing. You know, they're sealing the big leaks. They use blower door guided ways of finding the leaks and sealing them, make sure they did a good job. They dense pack 2x4 walls that have insulation in them already, anywhere between R2 to R11. They put an R15 dense pack in. And Dan, talk to Dan, he shows that he sees tightening just from the dense pack. So that's one thing. They use continuous insulation when they reside, when they have the budgets, and he can convince the architects. Energy Star, always put in Energy Star. They'll take the old vented attic, remove the insulation, seal the big leaks. They're bigger than what Mark says you can seal with this stuff. And then they can go in and air seal and then insulate again. And same thing with a crawl space. They can replace it. Insulated, they have been experimenting with slab on grade, you know, and a gut rehab, going down, not that deep, but at least getting the exposed portion of the foundation. They're also doing some innovative stuff. They're getting rid of gas and electric resistance. In most cases, they're going to ductless heat pumps. The Pochoa, what is that, Dan? That's one of those unit heat pumps, yeah. And what do they call it? The double decker PTACs with variable refrigerant flow. They're coming out now. So there's some cool stuff going on. Talk to Dan and Jesse about that if they're going to be here. And then upgrading to heat pump water heaters, as everybody's doing in the Northwest. And then PV on the roof when they're re-roofing. So all at the appropriate time in the life cycle of the gut rehab and the building. So where are the leaks that are bigger than the other leaks? And anybody that works in big buildings will tell you it's the shaft. So chat with Dan, chat with Jesse, chat with Dave and I, and Mark and everybody else here. Thanks. And Emily.
You want to do, or do you want to
Why don't you just go and then we can take them together.
advancing?
So Dave's going to take it from here. Are you all set up? All right, I'm going to shut mine off.
Oops. Okay, well, thanks for the great lead in. Mark did about half my presentation, so this should be very quick. Yeah, I'm Dave Bohac with the Center for Energy and Environment in Minnesota. Threw up a few personal slides there. So yes, Joe is correct. I am a aspiring pickleball player. Had to throw in a picture there. Minnesota though, so sometimes you got to dress for the weather. Might need a stocking cap outside. And then the middle picture there, well, this is for Duncan. You know, I know a little picture of our dog, Gilly, our elderly dog. I know how much Duncan just loves dogs, so I had to throw in this picture. And then other outdoor activities that we I enjoy is one on the right there is start of our 250-mile backpacking trip that we did on the John Muir Trail in California a few years ago. Just had a great trip. Actually, I was thinking about bringing in my cap there that has the championship in there for the Walter Cup. And I don't know if people, if they track women's hockey much at all, but you know, last 2 years, Minnesota women won the championship of the Women's Professional Hockey League. And of course, we managed to beat Toronto on the way there. So pretty happy about that. Sorry, Joe. What's that? Shout out to a couple of people that have been really instrumental in this. So Mike Lyon used to work for CE. He broke off and he started running an Aerobarrier crew. And then AeroSeal hired him. So he's an application engineer for AeroSeal. The last projects that I've been doing on Aerobarrier have all been with Mike. He's been great. Curtis Harrington is at UC Davis, WCEC. Worked with Mark on the development of the whole Aerobarrier process, and I've been doing R&D projects with Curtis, and a lot of actually what I'm going to be talking about today is work that Curtis did in California. So Mark did a great job talking about the inside-out method. That's kind of the traditional method. Pressurize the space, fog in the space, you seal from the inside out. So what I'm going to be talking about is some of the measurements that have been done, some of the R&D on the outside in method. So it's you depressurize the house now or apartment unit, you fog in the space that you want to seal. So it could be an attic, could be an unconditioned basement, crawl space, attached garage. You know, the real benefit of that is Mark talked a little bit about kind of the transfer of particulates. So reality is you're going to get some deposition on any space where you're doing the fogging. You can't avoid that. So if you're in an occupied space, you're going to get that deposition on all the horizontal surfaces. If you want to do this in occupied houses, apartments, then you've got to do all the surface prep to make sure that you don't get the deposition on surfaces you know, that need to be cleaned off. So question about, you know, making sure you take the prep off before you do the sealing, really good point, especially new construction, maybe not such a big deal. They don't have to do as much prep. You don't have to worry as much about removing that. But the projects that we've done in existing buildings, if you're trying to protect the floors and you have that taped down to real close to the interior walls, baseboard and so forth. It turns out that you can do a nice job where the sealant gets into those cracks, but then when you pull the poly off, then you're ripping off part of what you just sealed. So yeah, we've seen some unfortunately large increases in leakage when you remove prep in existing houses. So Mark already talked about the equipment, and I think really interested to hear about what they're doing on development. The heaters and also airless sprayers is going to be a big deal, not having to have those compressor lines going up into the attic space or down into the crawl space. So just a little bit about how this is going to work in attics. Again, I talked about, a lot less invasive, especially compared to the inside out method. Don't have to do any of the surface prep. So the big downside there is that all the surfaces have to be exposed. So you got insulation in the attic, and almost everyone does. It means you're going to have to be removing that insulation. So best case is that they had a plan to do that in the first place, so you can let them remove the insulation, go in there, do the sealing, and then they can re-insulate. Otherwise, part of the cost is going to be having to pull that out. So if you're looking for real extensive reductions in air leakage, maybe you can absorb that cost of having to remove the insulation, doing the air sealing, and then having to re-insulate. The other side, a bit of a downside is that you will get some of the fog to come through those leaks, so you are going to get some of the sealant in the space. So right now the protocol is to have occupants leave during the sealing period, and then the people that are in the space just use N95 masks to protect them from the sealant while the sealing is going on. So the plan was, when we were prepping for this presentation, was that we were going to have this great project starting up in January. We're going to have these wonderful results. I could talk to you about the work that we had done. Unfortunately, that didn't happen. So the good news is that Curtis Harrington had funding through CalNex for doing sealing on California houses and multifamily units. And then also just looking at setting up an agreement with ComEd to do some of the similar kind of sealing in the low-rise multifamily buildings in Illinois. So we expect that to be starting up this fall. So more to come, but today I'm going to be focusing on the work that Curtis Harrington and UC Davis has done with California houses and multifamily units. So overall goal there, demonstrate the effectiveness of this new exterior Aerobarrier process. Kind of what do you need to do from the kind of traditional method and modify that when you're fogging in attics and crawl spaces. And then what kind of performance can you get when you're doing that kind of thing? Document what the changes in the protocol is so the next group can learn from that work. Just a little bit about the houses and the multifamily buildings that were sealed. So they did 5 single-family houses. 1 was attic only, 2 were crawl space only, and then 2 of them were attic and crawl space. And then they also sealed 11 multifamily units, and all of that was attic only. And interesting thing on some of those projects, I think is mainly the multifamily, they compared the Aerobarrier method to kind of manual methods. So one was using an elastomeric kind of spray on. I'll show you a picture of that later. And then the other one is just kind of a standard can foam sealing. And how did the Aerobarrier compare to those 2 approaches? So here's the results for the 5 single-family homes. You can see, leakage reductions anywhere from 3% up to the 49%. So if you include all of them, average of 34%. If you exclude site number 4, where there were some unfortunate conditions, then actually an average of 42%. So if you're thinking about how that compares to normal weatherization, so if you're doing attic bypass sealing, maybe 20 to 30% on average. So you're certainly doing better than that. And Just need to point out too that this is the reduction kind of not for just the house to attic barrier, but it's for the whole house. So just by doing the Aerobarrier sealing in either the attic or the crawl space or both, average reductions of 42% if you throw out the one site. So pretty effective sealing. I'll go through just a few of those sites. So site number 1, 1900s, they were doing a gut rehab. This was crawl space only, so it was crawl space, a small basement that was attached to that, and ended up getting 38% reduction in that situation. And the nice thing about that one is that there was access to the outside, so they could do a guarded test. So instead of just being able to talk about what the leakage on the whole house was, they were able to do the measurement of what the leakage was from the crawl space and basement up to the house kind of before and after. So before they had about 283 CFM50, and they actually got 87% reduction on that house basement, or the basement and crawl space to house leakage. So pretty effective. And you can see, you know, we find this a lot, that when you look at the white pieces in there are where the Aerobarrier did the sealing, and you can see that, you know, even around where the can foam was, that it was doing sealing around there. And we often find that when we do use the can foam to do kind of seal the big leaks and have the Aerobarrier come after it, that there's all kinds of sealing that gets done around the spray foam. So site 4, and if we get into this one, I think actually Mark might have been to this one. You always have at least one that things don't work out quite the way you had hoped. So they have partial crawl space, slab on grade. They were doing only the crawl space. It turned out that it was going to be very difficult to remove the attic insulation, and only a 3% reduction. So they were on site, 60-degree rainy day, so 100% relative humidity outdoors. They were using a propane heater to heat the space, so they were trying to boost that up. But even with that, only a 3% reduction. So it looked like, my interpretation of what they found is the leaks that they did have between the crawl space and the living space must have been on the large side, so that they weren't able to get much sealing on that. And I know they were only able to operate at 70 Pascal. They like to try to run these days at 100 Pascals if they can get up there. I think they had a damper on the fireplace that was open, so they were losing a lot of their kind of flow pressure through the fireplace. And then as an indication that there was leaks between the crawl space and the house, they were getting fogging up into the house area. And so partway through it, they opened up a patio door to help kind of dilute the fogging in the space. And then that would just cause you to lose a little bit more pressure. Site 5, kind of one of the sites that did work out well, 1970s construction. The interesting thing about this one is that there was ductwork in the attic. So the main focus on these is to do the envelope sealing, but if you have ducts in there, there's an expectation that you should be able to do duct sealing with this approach too. So in this case, they ended up having to, so it started out at 12.7 ACH 50 to do some manual sealing, combustion air ducts, some HVAC equipment that was being replaced, got down to 8.5, and then did the Aerobarrier sealing for an overall reduction of 49%. And then they did a total duct leakage test before and after. And so they were able to seal 133 CFM50 or 34%. And that picture there is of the ductwork. So the ductwork had fiberglass insulation covering it. So actually not a lot of the joints and leakage was exposed. So with the Aerobarrier approach, if you've got fiberglass insulation, almost any kind of insulation acts as a great filter for those particulates. So any leaks that are behind the fiberglass aren't going to get sealed. So In this case, they didn't really maybe intentionally do the duct sealing. And if they wanted to get more duct sealing, you would have had to pull off all that insulation. But 34% reduction is a extra bonus. And certainly if you would have tried to expose all of that duct work, probably would have gotten another 3/4 or 1 ACH 50 out of that ceiling. So the first multifamily building that Curtis and UC Davis did, these are, I think, single family, 2 stories. So nice average 55% reduction just by doing the attic, and actually really consistent, 52%, 54%, 57%. And again, this is just doing the attic ceiling, nothing else. No walls, no windows, 55% reduction, which to me suggests that's a pretty high percentage of whatever house to attic leakage there was. And that was a site where they were doing a comparison between the Aerobarrier. So those are the bars on the left, 55% average reduction. They also had 3 units that they were using the elastomeric, which is that blue, the top picture with that blue elastomeric ceiling. And then they were using the can hand foam. So you can see on the elastomeric, same kind of buildings, 26% reduction for the elastomeric, 14% reduction for the kind of can foam, hand foam. So certainly much better. And the last site, talk about 8 multifamily units. And what they did in that case was they had 4 of those where they just did the Aerobarrier. And then they had 4 where they started out with can foam and then followed up with Aerobarrier. And all of those are attic ceilings. So on the ones where they just looked at pre-post on the can foam, average of 14% reduction, 8 to 19% range. The ones where they did just the Aerobarrier, so average 39%. With a range of 32 to 50%, so pretty significant reduction. And then on the ones where they did the manual sealing first and then followed up with the Aerobarrier, still ended up with a 39% reduction, so probably not that surprising unless the can foam was sealing big leaks that wasn't going to get done by the Aerobarrier. But what they were finding with it is that their sealing times reduced. So when they were doing the Aerobarrier only, they averaged, it was 88 minutes to do that sealing. But when they did first the can foam and then the Aerobarrier, their sealing time dropped down to 50 minutes. So that's the one thing that you get out of the can foam is get the big stuff first, make sure that those larger gaps get sealed, and you'll reduce your overall sealing time. So just some of the pictures about what these seals look like. Anything that's kind of a white powdery, that's the Aerobarrier being sealed. And just more examples of those 4 units where they started with the can foam, followed up with the Aerobarrier. You can see how the white Aerobarrier does a nice job of filling in the imperfections from the can foam. So just kind of wrap things up. Some of the barriers to being able to use this process, first biggest one is needing to remove insulation. Second is that rule of thumb is it'll seal up to 3/8 of an inch. If you don't mind sealing longer, you could seal up to 1/2 or 5/8. I think typically anything that's 3/8 of an inch, you'll probably get in the first hour and a half, and you'd need to seal longer for wider gaps than that. Tenants are going to have to leave for a couple hours while you're doing the sealing. Maybe over time, we'll get more comfortable with allowing them in the unit, especially if they're using an N95 mask. Certainly going to be more expensive than just kind of doing the can foam or hand sealing. And as Mark's talked about, they're in the process of developing some equipment that should make this go a lot quicker and a lot easier. But it's a nice opportunity. So again, if we're talking about, normal attic bypass ceiling with weatherization, 20 to 30%. On the single family, if we remove the one site, 42%, multifamilies, almost 40%, comparing to the can foam and the elastomeric with much lower. The nice thing, again, not much prep, pretty much no prep to the occupied space. So you can have a completely furnished house or apartment unit and still go ahead in and do this kind of ceiling. And then I think remains to be seen how things will go with duct ceiling, but certainly if you can do duct ceiling for ducts in the attic, it's going to make it even more cost effective. And as Mark said, new equipment coming out there. If we get the airless sprayers, it'll make it much quicker. So you can just grab the injection kind of modules and bring those up in the attic. So we're looking forward to that development. And with that, I guess we'll open it up for questions for Mike and myself.
I think you covered this. Can the air barrier, the aerosol be applied over closed or open cell? And I'm thinking of a botched foam insulation retrofit. Ask me how I know. But it can't. Will it here? Can it? I think you covered that. Can it be sprayed over foam insulation?
Yeah, and I think one thing to keep in mind is that the Aerobarrier in general, you're not coating an entire surface.
Mm-hmm.
This is kind of like automatic caulking. It goes to the gaps, it fills in the gaps, and not the complete surface. So,
in other words, if the foam retrofit gets botched, getting the guy back that botched it to fix it can be a vain act.
So, being a roof guy, I just was dying to know the whole time, how are you preventing the AeroSeal in the attic from blocking all of my roof vents, my intake and exhaust?
yeah, so you're pulling on the house, you're sucking on the house. So in general, the air is going to be coming, through the vents down. But, with a lot of attics, the amount that they're vented, even if you're depressurizing, so 75 pascals, 100 pascals, you may only have a couple pascals, between the house and the attic. So you're really not sucking that much. So if the short answer, if the wind is in the right direction, you will get some fog going out some of the vents. So I would say if it's large openings, it's not going to be a big deal. If you have fine screens, then that could be an issue.
So you don't get
So I think that this outside-in method is great for existing homes. My question is about for multifamily applications, going back to what Luby had listed as the kind of motivations for doing this, obviously not just energy efficiency, also, odors and noises between the units. How it seems to me that doing this from outside in versus inside out, you're missing that potential to seal between the units, the compartmentalization between the apartments. What have you found a need to implement another sealing method for those walls between the apartments, or is that just something that you kind of seal at the attic or the crawl space or both and hit your target regardless?
Yeah, if you're looking to do compartmentalization, you're going to have to do the inside out, because going from the attic down, you'll get that part of the envelope, but you're not going to get anything unit to unit.
Steve has been working on those individual from each apartment. And what we're starting to talk about is applications where there's a turnover of a tenant as opposed to whole gut rehab, and looking at the potential of compartmentalization benefits there.
You could, if there is a vacant unit, you could seal from that unit
Exactly.
and
Yeah. Jesse, you guys have done some of that stuff, right? There's Jesse over there. He's a guy to be talking to. And Dan, where's Dan? Dan's over there. So.
right, right. Yeah, it's going to benefit both of the neighboring units whenever that one is unoccupied. Okay, great, thanks.
Okay, side note, I think realtors should be paying attention to what you're doing. I want to go back to the fog because I just wasn't convinced that you have this fog and you're like, oh, let's open the door and let the fog out. This fog is not settling on my nice carpet or on whatever was not actually potentially covered. Can you really convince me that that fog is not something that a client's going to be like, I got all this slight goo over most of my house. Can you, that was my concern. You describe it as the fog, oh, you end up being a fog, but if fog was actually moisture, then most of my house would be wet. So I'm just trying to understand the fog.
Well, I mean, one thing, and I should also ask Mark just to go ahead and come up here too, and he can respond to some of these questions. But yeah, I mean, you're getting I'd just say a fairly dense fog like in the attic or in the crawl space, but most of that is getting kind of stuck onto the gaps as it comes through. You will get some blow through and you will get some of that. And I mean, Mark talked about having occupants. You can kind of smell it a little bit. And I think we're looking at doing monitoring of what those particulate levels are and see if whether we can get some quantitative feedback to the people that are doing sealing. But I mean, in general, all of what Curtis has done so far and what we've done is that the deposition really isn't noticeable in all of the ones that we've sealed so far.
Yeah, caution on the particle monitoring because you will just clog your monitor. So that's one of your glitches.
Not at the concentrations that they would be at. So about the fogging in the house, I think there's one thing worth noticing. So I was in the house he was talking about. I was in that house. It fogged more than any of the other ones we were in. And it looked foggy, but after we were done, there was essentially nothing. You could touch every surface because I do know what it's like to feel surfaces with stuff on it, right? When we do new construction. So I think part of what saves you is the only particles that get through the leaks are the smaller ones. It's not like there's just one size particle. There's like a spectrum of particles, and it's only the smallest ones that tend to get to pass through the leak. And those ones don't represent hardly any mass at all. You don't need much. Think about if you just took dust. I do a lot of woodworking. If you just took some dust and went up in the air, it looks like a lot of stuff, but in the end, it's not that much. So I can't say it's never, ever going to be a problem, but at least my experience has been that something that looks foggier than I would like doesn't seem to have the impact that you'd be concerned about. And by the way, in that picture up there, that I was at this building too, you can see the fog coming out of the vent.
One of the things that the Aerobarrier dealers, as we talked.
You got 30 seconds.
All right, getting into not having to put plastic down and the risk associated with grandma's Steinway. So we're avoiding all that by going from the Audi Innie.
Okay, quick one. Cost question for Dave. You said the retrofits were $250 a square foot without Aerobarrier, but you didn't tell us what they were with Aerobarrier, with the labor savings. Or no, sorry, the first presenter.
Yeah. No, speculate on the typical cost there, but I know in the Washington market, it was about $1.50 to $2 a square foot, but I'm not at liberty to talk prices.
Well, I could be at liberty, but I have no idea.
Well, I guess I meant for those
Honestly,
particular
I
jobs.
don't know. The only prices I've heard is like new construction. I don't know anybody who's doing it in existing buildings. But in new construction, I thought it was a dollar a square foot kind of thing, but I could be wrong.
As we're getting more people doing it in Washington State, we're seeing the price come down in the
Yeah.
competitive market.
And the people I've talked to at AirSeal say that the out-in should be about the same price as new construction.
Yeah, my curiosity was like weighing that with the labor savings on those retrofit projects.
All right, so my question has to do with durability. You're an early team in Philadelphia trained on our building, historic passive house in Philadelphia. That was about 7, maybe 8 years ago now. Have you done any testing, years later to see the durability of your product?
I think this has got to be me. I think that I tried to answer the question before about what we've done relative to durability, like trying to beat up the seals. But in terms of going back to buildings and testing the building, I don't know if we've done that or not. I don't think we've done much of that.
But does it get brittle or,
No, that's the stuff we test in the lab, right? We test for it becoming, does it stay rubbery and things like that when you heat it up. So there are protocols for testing plastics where what you do is you heat it and I forget what it's called. There's a certain temperature you have to go to, right? And then keep it at that temperature for a certain amount of time and then look for changes in the performance. And it's past all of those things, but I don't know. I mean, honestly, I don't know how a manufacturer, when you go to the store and you buy caulking, how they can say this is 50-year caulking and this is 35-year caulking and this is 25-year caulking. They didn't wait 50 years to give you that answer. So I think they have to do a similar kind of plastic analysis thing like that we've been doing.
All right, last question, but you bug them in the hallway. Okay, go.
You mentioned that with the outside, the attic seal strategy, the existing insulation needs to be removed as a part of that application. Have you done any testing with insulation in place? I just think that in a lot of circumstances, that might be a difficult
Have
barrier.
we tried?
Yeah.
I just say we tried a new construction house when the fiberglass bats were in the walls and the ceiling was terrible. I mean, it's fiberglass bats are a great filter for the sealant. So those leaks need to be exposed.
They're also a filter for moisture.
It is not going to seal through fiberglass. I can say that
That was meant as a
definitively.
joke.
I'm
And
thinking like
that-
existing
Gosh,
attics
right.
where you have very thin layers of old, decrepit fiberglass that's often not getting removed before they're going to loose blow the attic, as part of a mass save program or something like that. I wonder if it's still able to get through enough of that to seal as good as it can be, given we're not getting good sealing as is.
I would think that even an inch is enough to filter it. Yeah, we tried it one in commercial ducts where they had ductboard and it just, you have to cover the entire surface in order to get it to seal. It never gets into the leaks.
Actually, ductboard is way easier than trying to do in the attic. It would only be if there are parts that don't have any insulation on them. Like if you imagine the top plate, if the insulation is below the level of that, it would seal those leaks. As for ductboard, you can seal ductboard. It's just painfully slow.
Yeah.
And you don't have to do the whole thing.
Last question.
I'll make it super fast, I think. Working on a retrofit, it's a row house. We've got neighboring buildings, they're party walls. My assumption is we have to pressurize both neighbors just to use the product, or is there a better way to do it? In other words, I don't want any small air seal going into my neighbors' houses. I'm assuming you've done that before. Thoughts?
Do you want to, I would say that, if you want to make sure nothing gets over there would be to pressurize the adjoining apartments, or in that case, the adjoining row house, and make sure that you've got no pressure, driving in that direction. The other option would be open up the windows, make sure it's anything that gets in there is going to get diluted real quickly.
All right. Thank you. Woo-hoo.